Alright, hello again everybody. Today we're going to be doing another hardware video, but instead of going over a bunch of basic parts, what I'm actually going to be covering today is what I'm calling competition hardware. And so this isn't directly related to a competition, but what I really wanted to cover here was just sort of hardware strategies and different modules that are not quite parts necessarily, but concepts that I think are really, really crucial to having a really outstanding robot at competitions, and that's kind of where this name's coming from. So the four that I want to cover here today, the first one's going to be the intake, then we're going to go to slides, sensors, and then cameras. And I'll have examples of how these have been used in previous robot games throughout the presentation so that you can also get an idea of what kind of game environment it could be used in. So starting off with an intake is essentially just a mechanism that is able to suck objects into the robot. And usually an intake runs on the compliant wheels that you might have remembered from our last presentation on basic hardware parts. However, I've also seen intakes made out of all sorts of different things. People have used rubber bands at a certain tension, wheel tread, if you remember that from the last presentation, and even just mechanical claws and pieces of metal that just push things into the robot. Because by definition, an intake doesn't have to look like this. It can look like anything that you want it to, as long as it serves the same function. And so intakes are really useful for games where you have to pick up materials and transport them to different locations because it's just the fastest way to pick something up, and then it'll be in the cargo hold of your robot. You can move it to another part of the field and then have another module that somehow deposits it. And so here's an example of what an intake would look like when it's running, and this is from a couple years ago. And so as you can see, these compliant wheels are really good for the intake because they're able to flex in a little bit, they're able to compress, and then when they compress around the cubes that were being intaked, then the cubes are pulled in as the wheel rotates. And so you're able to suck in those cubes really, really quickly. And moving on to slides. Slides, I'm sure the definition is pretty intuitive, but they work the same way that you would think of a Home Depot drawer slide as working. And that's actually a funny thing I just said that because Home Depot drawer slides are a very common type of slide that teams will use because essentially what you use slides for is to have an extended range of horizontal motion, but then also an extended range of linear motion, depending on how you mount the slides. Now, there are many different types of slides, different companies, different models in a way, but they all serve the same purpose. And so in the two videos up on the screen, I'll show you guys both of them in a second, but here's the first one, and you can see it has this horizontal slide extension. And so it's able to extend this little pickup container further out into this depot area to pick up these game elements. And so instead of the robot having to drive into the area to pick up these things, the slides can just extend and it picks it up much faster. Now here on the right side, we have an example from a different nearest competition, but this actually shows you that vertical motion I was talking about. And so here you can see that the slides are going up and down in order to allow the claw to stack objects on top of each other. And so what this is really useful for is for making these kind of towers, because this is really just the easiest way to get the height and the range that you need vertically. So as I mentioned, there are many different types of slides. Here are four of the really popular ones that I've observed in competitions and that MSET has used previously. And so starting off with the drawer slides I mentioned. So these are just standard Home Depot drawer slides. You'll literally see them on many different types of desks and cabinets and whatnot. But they're really heavy duty. They're also really heavy because of that. And they're not quite meant for robot competitions, but because of all the holes that are in the drawer slides for them to mount into an actual drawer, it's actually not too overly difficult to mount it onto a robot. And so if you need something that's super duper heavy and sturdier on the bottom, drawer slides are pretty good for that. Extrusion slides are obviously the basis of it is that it's made out of extrusion, but generally what you actually do is you use your own extrusion and then you buy what's called a linear motion kit. And so this allows you to put rollers and stoppers onto your pieces of extrusion so that it acts like slides. And this is a really lightweight and cost-effective way to do it because obviously you're not paying for the entirety of the hardware. You already have the extrusion. You're just paying for the linear motion kit. However, extrusion slides are not super durable just because extrusion is a decently lightweight material. There's a lot of holes and whatnot in it. And the linear motion kit means that the parts aren't going to be flush. There is going to be that little bit of space in between, as you can see right here, that allows it to wiggle around a little bit. So extrusion slides aren't great for really heavy duty purposes, But again, cost effective, lightweight, they're pretty small as well, so these are a really nice option. X rails, on first glance, look pretty similar to extrusion slides. However, what's different about X rails is that they were designed to be one compact system, and it's not visible in this picture, but there's this surgical tubing that runs in between each stage of the slide. And what the surgical tubing does is it provides that kind of resistance that allows the slides to collapse back into each other, not only more consistently, but also much, much quicker. And X-rail slides are a little bit more heavy duty and durable than extrusion slides, and also still pretty simple to mount just because the basis of it does look a lot like extrusion. Now the last option on the screen, the last option on the screen, and this is a newer option, at least in the FTC world, but it's become very popular very quickly, is slides made by a brand called Misumi. And so the really nice thing about Misumi slides are that they're really, really lightweight, much more than the other three options you have on the screen. But they're also able to support those kind of heavy-duty functions and then screw into each other, so you can get a ton of different stages of slides without it collapsing inwards or having a little bit of that weird wiggle room. Misumi slides are also not overly expensive considering how nice they are for applications, but obviously there's no one slide that just works for every single application better than all the other ones. So my recommendation is if you're planning to use slides either horizontally or vertically, you should have a team member or multiple team members doing research into the types of slides, looking into every single option that you could possibly have, so that at the end of the day you know that the one that you chose is the best possible option, and that you didn't overlook something that in the future you might regret having not tried. So now we're going to go on to sensors. So sensors, you probably know what they are, but they're a way for the robot to receive more input from its environment and its surroundings than it is able to through just the motors and the servos. And so there are many different types of sensors. The most common ones you'll see will be distance sensors and color sensors, but there are also gyro sensors and limit switches, which are both pretty popular in FTC. So they all have pretty intuitive definitions from the name. The one you might not be able to guess is the gyro sensor and the limit switch. So the gyro sensor is able to detect sort of orientation on the field. And in the Rev expansion hubs, there is an integrated gyro sensor, but there are some teams that use external ones to get a little bit more input and a little bit more accurate reading from their sensors. And a limit switch basically just detects if an object is being touched. So it functions a little bit kind of like a button, where if you're pushing it down, the robot receives one type of input. If it's not being pushed, receives a different type of input. And in this example in the video, you'll see an example of a color sensor that was used a couple years ago to detect the difference between these two ball colors so that the one of the opposing alliance could be knocked off. And that was one of the ways to score points during the autonomous period, which is why a sensor is used as opposed to human control. And now we're going to go on to what cameras are. And so you obviously would know what a camera is, but in the purpose of robotics and FTC, a camera is used for vision. It's used to give your robot almost eyes so it can see the field around it and make some kind of interpretation or deduction from its environment. And most teams these days have started using external cameras. So some teams have been using the camera on the back of their robot phone, but external cameras give you that flexibility to mount it wherever you want on your robot. You don't need to be able to accommodate the entire clunky phone. And an example of how a camera could be used is in this video here. You'll see that the robot has to intake the yellow cube out of the 3 game elements lined up in front of it. And it could use a color sensor, right? It could go through and check the color of each one. But what a camera allows it to do is take the entire view field into effect at the same time, identify which color is not the same as the other two, and then it can tell the robot what instructions to follow in order to intake that one cube. And so color sensors and cameras have different purposes depending on what you need it for. But the things just to know about a camera are that you do need to mount it very precisely. You can't wiggle around too much because you want to keep that frame of reference the same. And then also it gives it a larger frame of reference than a color sensor does. So they're useful for different purposes. And so here you can see that the robot is able to intake the yellow cube no matter which position it is set on, because the camera is able to see all 3 of the game elements and then identify which one it is. And so that wraps up the 4 things I really wanted to cover with this brief presentation. You saw how intakes worked, how slides worked, sensors, and then cameras. And so this is obviously not every single type of strategy or hardware element that you could see on a robot or that might be the best for your robot. These are just the 4 that pop up year after year and are really, really crucial to understand in order to have a good variety of options to pick from when designing your first few robots. So if you have any questions, feel free to contact me on the MSET training website. Otherwise, hope you have a great day, and I'll see you in the next video.